Baffling boundaries of the human brain. Why our minds can't handle the universe. Dear viewer, imagine handing a microscope to a chimpanzee. It might poke at the lens, chew on the eyepiece, or fling it across the room, but it would never grasp the hidden world of cells, bacteria, and quantum foam lurking. Now, take a step back and realize, we are that chimp. Oh sure, we're a slightly more sophisticated primate. We can do taxes, write poetry, and microwave a burrito without setting the kitchen on fire, most of the time. But when it comes to truly perceiving and conceiving the universe in all its infinite, multidimensional, quantum-weird glory, our brains are woefully, hilariously underqualified. Let's take a journey now, dear viewer, through the glaring gaps, baffling blind spots, and humbling hiccups of human cognition. Sensory shortcomings. The universe is a kaleidoscope, and we're color-blind. Our senses are like a dollar store radio tuned to exactly 5 scratchy stations: sight, sound, squishy touch, questionable smell, and "is this sushi bad?" taste. Meanwhile, the cosmos is throwing at us a full sensory extravaganza of radiation, quantum vibrations, and interstellar aromas. The light we cannot see. Human eyes detect a pathetic 0.0035% of the electromagnetic spectrum, visible light, whereas the universe paints masterpieces in infrared, ultraviolet, radio waves, X-rays, and gamma rays. We cannot directly perceive dark matter, which makes up approximately 27% of the universe, or dark energy, approximately 68%. Our eyesight is like a small, sad, grayscale box of crayons. The sounds we cannot hear. If a supernova explodes in space, can we hear it? Nope. Our ears are as useless in a vacuum as is a snorkel in the desert. Human hearing is restricted to a narrow range of frequencies, approximately 20 Hz to 20 kHz. We miss the infrasonic gossip of elephants and the ultrasonic shrieks of bats plotting world domination. The forces we cannot feel. Dark matter ghosts through our body. Gravity bends space-time beneath our feet, and quantum particles throw raves in our coffee cups. We cannot feel magnetic fields, quantum phenomena, or higher dimensional structures. The smells we cannot sniff. The Milky Way likely reeks of raspberries and rum, thanks ethyl formate in space dust. But our noses are too busy detecting wet dog and weird supermarket smell. Meanwhile, sharks can smell a drop of blood 800 feet away. And us? Well, we can't even tell if milk's gone bad without a cautious sip. The flavors we cannot taste. The surface of Mars might be laced with perchlorates, red, rocket fuel flavor, but our tongue is too busy debating whether cilantro tastes like soap. Dogs have 1,700 taste buds for water alone. Us? Well, you, dear viewer, think Sriracha is spicy. According to Friedrich Nietzsche, we are like spiders in our own webs, and whatever we may catch in them, it will only be something that our web is capable of catching. Brain buffering. Our wetware is overclocked and overwhelmed. Our brain is a 3-pound lump of mildly electrified fat that somehow convinced itself that it understands the block universe theory. Let's smile at its limits. Working memory woes. We can hold about 7 things in our head at once. Miller's Law. That's why phone numbers were originally 7 digits long since any longer, and our brain blue screens. Now try imagining 11-dimensional string theory. Good luck. Slow neural speed. Human neurons fire at a pokey 120 meters per second. A computer signal travels at near light speed. This is why you take 5 minutes to remember where you left your keys, while artificial intelligence does calculus in nanoseconds. Cognitive biases galore. We see faces in toast, assume the sun revolves around us, thanks ego, and think correlation equals causation, like a medieval peasant blaming witches for bad weather. Metaphor alert. Our brain is like a 1982 Commodore 64 computer trying to run a modern VR simulation. It's adorable that it tries. Uncertainty, the brain's nemesis. Perhaps the most frustrating limitation of the human brain is its aversion to uncertainty. We crave answers, definitions, and resolutions, yet the universe often refuses to oblige. Quantum mechanics, for instance, revels in uncertainty, with particles existing in superpositions and outcomes determined by probabilities. The brain's discomfort with uncertainty is akin to an amateur detective trying to solve a mystery where the clues keep disappearing. It forces us to construct mental shortcuts such as hypotheses, assumptions, and beliefs that may not reflect reality. While these shortcuts help us navigate daily life, they are woefully inadequate for deciphering the universe's enigmatic puzzles. Linguistic labyrinth. Supercalifragilisticexpiali. What now? Language is a double-edged sword, both a tool for communication and a barrier to understanding. Our words and symbols are imperfect representations of the universe, akin to trying to describe a sunset with only a ballpoint pen at hand. We might say that the universe is expanding or contracting, but these terms are mere approximations, failing to capture the nuances of cosmic evolution. Mathematics, often touted as the language of the universe, is similarly limited. Our equations and formulas are simplifications, abstractions that neglect the complexities of the universe. We might describe the motion of planets with precision, but our calculations are only as good as the data that feeds them. Scale struggles, from quantum foam to cosmic voids. The universe operates on scales so extreme that the human brain short-circuits in epic Danger Will Robinson fashion, trying to grasp them. Examples of quantum quirks, teeny-tiny troubles, particles existing in superpositions, multiple places at once. Curved space-time and wave-particle duality defy classical intuition. Two electrons can be entangled across galaxies. Quantum entanglement, whispering secrets faster than light, spooky action at a distance. The size of the observable universe, approximately 93 billion light-years wide, which is incomprehensible to a brain evolved for navigating small tribal territories or GPS coordinates to the nearest Starbucks. The vacuum of space isn't empty. It's a bubbling foam of virtual particles, quantum fluctuations. Our minds struggle with geological, billions of years, or cosmological timescales, deep time. Your chimp brain's reaction to all of this: nope, nope, nope. Cosmic confusion, colossal crises. Our brains evolved to track antelope on a savanna and basically survive, day to day, on a tiny blue marble, not comprehend galactic superclusters. The black hole's singularity is infinitely dense. Our brain hears infinity and responds, error 404, concept not found. Time itself bends near massive objects. We still get jet lag from a 3-hour flight. Due to anthropic bias, we assume the universe must be observable or understandable to us, but it may not be. Please note, dear viewer, that trying to imagine the scale of the universe is like an ant trying to comprehend the internet by examining a single pixel on a monitor. Dimensional dilemmas. Flat earthers in a hyperspace horror show. We live in 4 dimensions, if you count time, but let's be honest, you're late to everything anyway. Meanwhile, theoretical physics suggests there could be 10 or 11 dimensions curled up in every particle. Can you visualize a 4D cube, tesseract? No! Can you even draw a 3D cube correctly without it looking like a kindergartner's nightmare? Probably not. The human brain trying to grasp higher dimensions is like a goldfish attempting to explain stock market derivatives to a moose. Time troubles. Our brains are stuck in a linear loop. We experience time as a neat linear progression from past to present to future. But physics say time is malleable, relative, and possibly an illusion. Near a black hole, time slows to a crawl. In quantum mechanics, cause and effect can get freakishly fuzzy. The block universe theory suggests past, present, and future all exist simultaneously. We cannot perceive time at Planck scales, about 10 to the negative 43rd seconds, or cosmic scales. Our brain's reaction, "I'll think about that tomorrow." Spoiler, it won't. Mathematical mind-benders, Gödel's gremlins in the machine. Even math, our brain's last hope, has built-in limitations. Gödel's incompleteness theorems prove some truths can never be proven. See circular reasoning or reasoning circular for more details. Infinity isn't a number. It's a concept that makes calculators short-circuit in existential despair. Quantum probabilities mean we can predict odds, but never certainties. Some physical truths, e.g., infinity, singularities, quantum fields, may be mathematically describable, but inconceivable to human cognition. Dear viewer, our brains trying to understand quantum math is like a dog watching a magic trick. It's total confusion with a hint of misplaced confidence. Consciousness conundrum. Why are we even aware of this? Now here's the real kicker. Our brain doesn't just struggle with the universe, it struggles with itself. We still lack a fundamental understanding of how consciousness arises from the physical brain. The hard problem of consciousness. Why does a lump of neurons produce subjective experience? Why does red look red? Science has no clue. The illusion of free will. Your brain makes decisions before you are aware of them. Are you just a spectator in your own skull? The Boltzmann brain paradox. Statistically, it's more likely for a self-aware brain to randomly form in the void than for the whole universe to exist. Are we just a momentary glitch in the cosmic noise? Arthur Schopenhauer once said, "Every person takes the limits of their own field of vision for the limits of the world." Limits of observation to infinity and beyond. Nope. The speed of light. The finite speed of light means we can only observe a limited portion of the universe, the observable universe, as light from more distant regions has not yet had time to reach us. Technological limitations. Our current technologies, while constantly advancing, still have limitations in probing the universe at the smallest and largest scales. The future. Can we upgrade our mental hardware? Given all these flaws, is there hope? Maybe. Brain-computer interfaces. In order to transcend biological limits, future brain-computer interfaces may help. Neuralink will help us turn our brains into a Wi-Fi hotspot. Will it help, or just give us pop-up ads in our dreams? Both may be true. Artificial intelligence. AI might discover physics we can't even comprehend. Then it'll either explain it to us slowly or enslave us. Mathematics and models. Future math will allow us to describe realities beyond intuition, such as advancements in relativity and quantum mechanics. Technology such as telescopes, particle colliders, and AI will extend our perceptions. Genetic engineering. Future humans might have enhanced cognition. However, trying to upgrade the human brain might be like trying to install Windows 11 on a potato. The cosmic joke. and why it's beautiful. Yes, the human brain is a glorified meat computer with more bugs than a roach motel. But here's the twist. It's also the only tool we have to explore the universe. We've used our brains to decode DNA, land on the moon, and invent nachos. We've built telescopes, microscopes, and AI to extend our feeble senses. We've accepted that some truths may forever elude us, and that's okay. So next time you feel dumbfounded by quantum physics or the size of the cosmos, remember that we're all just a monkey with a microscope. And yet, against all odds, we're still trying. And that's kind of amazing. Remember, in the words of Lyle Watson, if the brain were so simple we could understand it, we would be so simple we couldn't. Would you like an even deeper dive into any of these cosmic conundrums? Or should we just accept our fate and go eat some nachos? I vote nachos.